Well, first I want to thank all the communities that support this meeting, because it's really great if you see in how little time everything came together, and there's such a huge event, and well, this is all made possible by the communities and Microsoft. So thank you for that. And having said that, let's dig into the session for today. We're talking about Azure Functions and a little bit of SignalR, and how to get some insights in what's actually happening in your Azure Functions. If you're not familiar with Azure Functions, let me just introduce it very briefly. An Azure function is basically a function as you already know it from your programming language, or a method, if you like. It's just a little piece of code that is executed, but before it gets executed, it needs a trigger, and it can have an HTTP trigger to have it triggered by an HTTP request. But also, if you're looking at Azure, we know blob storage, and we have several kinds of queues: the storage queue and the service bus queue. And all these mechanisms are attached to Azure Functions and are capable of triggering your function. Inside Azure Functions, you also have the capabilities of to use input and output bindings. And input bindings, you can grab stuff in your function. For example, if you want, if you have an Azure function with an HTTP trigger, with a certain parameter in it, you can use that parameter to directly download the content of a blob in your blob storage in Azure and have that available instantly. And on the other side, there's output functions. You can write stuff away to databases, to blob storage, to queues and whatnot. So that's basically a short introduction of Azure Functions. Then there's also SignalR, and SignalR is a real-time framework originally written by Microsoft, I believe. And if you know SignalR from the beginning, then there was this NuGet package that you used in your software. You download it in your development environment, and you start writing hubs. And hubs allows you to send signals, SignalR, to send messages to your front end. But in the first versions of SignalR, you had to write that hub in your programming language, and then press a magical button, and then a JavaScript got generated for you, which you needed to incorporate in your website, and that would allow you to use SignalR. Well, SignalR evolved over time and is now available for a pretty large amount of time. It's available for a while in Azure, but what's fairly new to the SignalR service in Azure is that it can run in server mode serverless. It's a server mode called serverless, and that allows you to use SignalR from within your Azure Functions. It was in a preview for, I believe, until 3 months ago, and then it became fully available. But now let's just give you a short introduction about why and how I came to this presentation. I'm working as a consultant at several clients, and I try to help them creating better cloud solutions. And this one client, they had an import function, and that import function was running daily, and it was a JSON file which was parsed and then validated and stored in the database. And they did. That client decided to solve the problem with Azure Functions, and I think it's actually a pretty good idea. But what they did is they made one single Azure function that did it all. So there was a HTTP trigger, and that HTTP trigger accepted the file, parsed the file, and then started validating the data inside that file. and then write it back to persistence to the database. But they had this problem that when the import file was growing and growing and growing and growing, the function ran for too long and ran into a timeout. By default, an Azure Functions timeout is 5 minutes. You can configure it up to 10 minutes, but if your function takes longer than 10 minutes to run, then you run into a timeout. So that was a problem for the client. And now, if you've been us for the entire day, at 1 o'clock, Mark Duiker gave us an excellent session about durable functions. You can use durable functions to solve this problem, but I think the cause of the problem is actually that there's a huge amount of responsibilities inside this function, which should be separated into multiple functions. And again, durable functions is really a good way to go, but I want to show you a different way to approach this problem. But again, doing everything in one single function, too much responsibility, your function will run too long, will run into timeouts. So this is not really the way to go. So let's just run through a list of things what to do when you're writing Azure Functions. Well, first of all, you have to avoid long-running functions because you'll be confronted with a timeout of by default 5 minutes, and you don't want to run into that timeout. Your function need to be stateless. You can store state in cloud mechanisms and then reuse that. But really, if you want some sort of a state, it may be wise to go to durable functions, because then you have the stage and all the your states and all the plumbing that you require for your state to be persisted available for you. And the last one, avoid the usage of large libraries. That's a really good one. If you want to use, for example, SQL Server, and if you tend to use Entity Framework, the client package, the NuGet package for Entity Framework is a little bit larger than 6 megabytes, which is fairly large for an Azure function, because it needs to load all that 6 megabytes to start an instance, and you want your Azure functions to be as small as possible and to start up as fast as possible. And those large libraries are not recommended. Use Entity Framework if you like, or large libraries, but please take that into consideration before you start writing your Azure functions. Now that we know how Azure Functions run, and we know that we want to redesign the original import of my client, we need to identify things that we think is important when you start importing data. Well, in my opinion, the first thing is that it needs to be reliable. If you present your data to the system, you want your data to be treated well, and you want some sort of insight in what's happening with your imported data. Sometimes this one is not always true. Sometimes you present the data and you don't care about how long it takes before the data is imported. But in most systems, users want some insights in what's going on, and they want to see what's going on, and therefore you want your import functions to run fast, because users may be waiting for the data to be imported. You want it to be fail-safe. And what I mean with that is that in case something went wrong, for example, the import data is incorrect, and your validation function says, okay, I'm not going to import it because the data imported is not valid. You want to store the data somewhere, or you want to do something with it and allow the user to correct the data and then retry, for example. And last but not least, you want insight. You want users to show users what's going on. You want to show users in what state of the progress they are, and maybe how many time is left for your import to complete. So that comes with the SignalR service in Azure. And now when provisioning a SignalR service in Azure for your Azure Functions, you first go to the portal, and then you provision yourself an SignalR service. And what you really need to do if you want to use them within your Azure Functions, again, please set the server mode to serverless, because it makes it really easy for you to use your SignalR service from your Azure Functions. And also, the SignalR service in Azure runs in a no hub mode. So what you're used to way back in one of the first versions of SignalR is that you have to write a hub and then allow messages to be sent to the server and send messages back from the server to the client by predefining functions that you want to execute on the client and also the payload. This new SignalR service has a no hub scenario, so you don't have to do anything of that at all. You just send a message or raise an event on the client, and also send a payload with that. And if there's a handler on the client, the message will arrive and will be processed to whatever you want to do with it. And then also it may be wise to look at the course settings for SignalR, because you're connecting with JavaScript. In this case, in my example, you'll be connecting with JavaScript, and then course rules apply. So you must configure your SignalR services so that it allows your connections to come in. So let's just go ahead and provision yourself a SignalR service. I already did that, so I'm just going to show you how to do that in the Azure portal. So I went to this page to provision a new service. I'll zoom in here a little bit, and I search for SignalR, and there's the SignalR service. Now, if I press this create button, I also have a resource group here, which is demo serverless. This is for today. You can get yourself a name. Of course, choose a region where to host it, and a pricing tier. Oh yes, the SignalR service is free. You can actually try this one for free. Please notice that there's a limit of 20 connections for the free tier. So this is actually a pretty good one to get familiar with the Azure with the SignalR service. But if you're running in production, you may want to move to the paid version, and that's the only two flavors that's available today. And then there's the server mode, and I'm going to zoom in now just to show you what I configured. So I had this virtual Azure Community Day SignalR service provisioned in Western Europe. I want the free tier, and I set the server mode to serverless. Now you can just go ahead and press review and create, and then create it later on. But as I mentioned already, I did provision a SignalR service, so it's available for us in this demo, and we don't run into problems provisioning it. So I just want to show you that my course settings, I just allow everything right now because it's the easiest for my demo. And again, in running in a production environment, you may want to configure this to more specific hosts. Also in the settings, here's the serverless, the server mode again. If you accidentally forget to switch your SignalR service to serverless, you can then do it in the settings here, and you'll be good. Don't forget to press the save button, which is often forgotten. So now we have our SignalR service. Let's just dig into the new import workflow and how we're going to do that. As I mentioned, Mark already gave this session at 1 o'clock about durable functions, which can be a very good solution for this problem. I want to show you a different approach, and that's a more event-driven solution. So what we're going to do is we assume that a file exists on my storage account. So I have this blob storage container, and I created an Azure function with a trigger on that blob storage container, which means that the Azure function will trigger as soon as a file exists on that location. I removed the HTTP trigger, which was in the original import, because I think it's wise if you have a web client or some sort of client sending a file that you use, for example, the valet key pattern, and have that file uploaded to the cloud immediately instead of having your web server in between, which causes a lot of traffic on your web server, and you may want to have to scale. You may have to scale your web server up and down depending on traffic, and that can be really expensive. And if you use the valet key pattern, you can just skip your web server and ask your storage account for a key and a location where to upload, and then upload it to your container immediately. So as soon as the file exists and is fully uploaded, my Azure function is triggered, and it starts parsing the file. So it opens the file and starts reading through each and every item or entry that needs to be imported. And each entry will be stored on a queue. Now for this demo, I used a storage queue because first of all, it's very cheap. And second of all, I don't really need the fanciness that service bus queues deliver. I just want to stack a lot of work on the queue, and I want another function to handle and process all these messages and then get rid of them. And the storage queue is a really cheap and fast solution to do that. Also, I'm importing my data to storage tables. So what I did was I provisioned a storage account, and I used the blob storage to upload the file to. I used the queue to send messages to and distribute the work over multiple instances of Azure Functions. And I used table storage to write the imported data away. So that's really a good and cheap solution for this problem. But of course, the storage table storage has also its limitations, and if you want some more fanciness on your queues, you may want to switch to the service bus. But for example, if you want to import to SQL Server, you have to provision yourself a SQL Server instance. Okay, having said that, now messages are sent to the queue, and my files parsed, which actually gave me some insights of the work to do, because I iterated through all the entries that you want to import. So I know the amount of import entries we're talking about. That means that I can actually send the first message to SignalR. Hey, I saw a new import coming in and I know what to do. This message could also be, hey, a file was uploaded and I don't understand this file, I cannot parse it, and then present an error. You see that there's a queue in between, the reporting queue, and I use this queue to also store an entry in table storage. And that means that immediately after parsing the file, I generate a correlation ID that identifies the entire import process. And this reporting queue allows me to save, to trigger a new Azure function and save that correlation ID with the amount of entries that I'm going to import, and maybe the date and time that the import process started and whatnot. I can store that into table storage so that users can later on collect all the data that was generated by the import process with the same correlation ID. So now this a huge amount of work is stacking up on my storage queue, which actually triggers a new validation function. And as you can see, my funky animation, this validation function will scale because there's a huge amount of work on the queue, and Azure detects that there's a huge amount of work on the queue, and then will scale my validation function and to multiple instances. So the validation work will be finished quicker. You remember in the star situation that was at my client, it's one function, and this one function will only scale if there's a huge amount of files sent through that HTTP request. And this way, okay, for the parse file function, there will be one instance per uploaded file, but the validation work will be distributed over a huge amount of instances, making the work complete very fast. This validation function, let's just assume that my data is valid. So this validation function will check my data, and as soon as it's valid, it will store the exact same message again on a different queue. And then there's this import function, which will also scale because there's a huge amount of work on the queue. And this import function will actually write my data into persistence. I drew Cosmos DB icon here, by the way. But in my demo, it's actually stored into table storage. But then again, I want to report. I want to write and send some messages to my client about the process, what's going on. So what I did there was I again write a success message to a queue, which is handled by another Azure function, which will then again report using that same correlation ID. Hey, I have an update about this import function, and this is the current status. So again, if you saw Mark's session, you see that there's a lot of plumbing here going on. For example, the correlation ID and some sort of well, call it maybe orchestration that you need to do yourself, which you'll get for free using durable functions. But I think this is a really nice solution for this problem. Now, what we're missing is what happens when something goes wrong. Well, again, your file can be incorrect. You can upload I don't know, an image file, JPEG, for example, which cannot be parsed as a JSON file. So you need to report an error. And also validation can go wrong. Of course, data may be invalid. Now, in my demo, I'm importing users, and I added a validation rule that users cannot be older than 80 years old. And if they're older, the data is considered to be invalid, just for demo purposes. And also, of course, during the import itself, for example, the persistent store may not be available anymore. So the system fails to write data into persistence, and you want to also report that error and then handle it. So there's an error queue, which is handled by, I believe, the last Azure Functions for this entire solution. It will handle the error. And then I believe this last one, the orange persistence, is really important. This orange persistence is storing the error message, but also the original data entry that was passed from within the import file. And that allows me to, for example, if there's 1,000 users in my import file, and 50 of them fail, that means that 950 are successfully stored in persistence. But the 50 entries that fail will be stored in my error persistence, and that allows me to show what is wrong with the data to my user, but it also allows my user to correct that data and then retry the import of that single entry. Now, when I gave this session in Poland, there was a guy with a question: what are you doing with transactions? For example, I want my import to fail or succeed. If everything fails, my import is fine, and you're good to show the imported data to the user. But as soon as one entry fails in my entire import, I want the entire import to fail. Well, obviously, I didn't take that into consideration designing this workflow. But what you can do if you're using this workflow, as soon as you write it, your entry into persistence, you can then flag it using the correlation ID and flag it as temporary. And once the import completes, you can then remove that flag and making your data available. If you wanted a true transactional model for this, you may want to use a different approach. So let's just dig in and show what I created. So I'm going to Visual Studio. This is the solution. Let me zoom in on my screen a little bit to make it a little bit more clear. So this is my function actually being triggered. As you can see right here, I have a blob trigger. And you may not know that if you use this trigger, in the end right here, whoops, there's a name, and you can actually inject that name into a string variable right here that you can use later on. You can see, for example, my log message here, hey, a file with this name came in. And then I just whoops, let me zoom in once more. Right here, you see that I iterate through the file and store a message on the validation queue for each entry in the file. Also notice, by the way, that I generate this correlation ID and send a status command to the status queue, which allows me to, from then on, track the status of the entire import process. And again, if parsing the file fails, this right here on the bottom, I also send a status message to the status queue with an error message. Hey, the file could not be processed, no import was done. This is my Azure function actually reading that status information. There's two different queues. One is the status create. As you can see right here, this one is reading my status create message, and it actually starts and creates a new entry in table storage with all the data that is available for me for my import process. So this is obviously a partition key and a row key because I'm using table storage. When is the entry created? The last modification is also now the total amount of entries and the total amount of errors, and an error message if the entire import fails, and if a single entry fails, that will be stored in a different table and table storage. And also there is this status update. For status update, I use a slightly different mechanism, because as soon as a message exists on the queue, I will store it into table storage, and then another function will run with a slight delay, and that function will grab all the status messages of the same correlation ID together and then send a message to SignalR at once. Because else, if you're importing a huge amount of data entries, then a huge amount of messages are being sent to through SignalR, and this allows me to grab a couple of status messages and send them at once. Now this real-time function, I created that to allow my SignalR client to connect to this my SignalR service. What you need in your project settings is an SignalR connection string, which is available on the Azure portal. You can just copy and paste it in your project configuration, and what this function does, it's actually a HTTP triggered function, and your SignalR client will connect to this endpoint, and this function will then grab the connection string and then pass that to the client, which allows the client to actually connect to the SignalR service. So you don't have to know or configure the SignalR endpoint and all the secrets in your client project. You can all leave that server side and store that in Azure Key Vault, for example. Well, and again, here's my the last one. This is my last function, actually reading the import validation queue, and it starts validating messages. And as soon as the data is valid, it will store messages into the import success queue, which will then store my data into persistence. And if the validation fails, it will store messages on the import failed queue. And as you can see, I have only one validation message right here. As I already mentioned, if a user is older than 80, I don't know why I created this validation rule, but if a user is older than 80, I want the import of this entry to fail. So now if we go, let's just stick right here for a second and open the Cloud Explorer. As you can see, I have no tables at this moment. I have a couple of queues. I have this success queue for messages that are validated successfully, and I have this failed queue for errors. I have the validation queue, obviously, for validation messages. And as I already mentioned, I need some plumbing for the status messages. So I have a process message, and I have an update message, and I have a create status message queue, so that I can handle statuses accordingly. Now I have this blob container with an import blob container. I'm sorry, and as soon as a file exists on this blob container, it will actually trigger my import function and start the import process. And so let's just go ahead and do that, because one advantage of an Azure function is that Azure Functions can be really cheap. If you run the function in a consumption plan, you actually pay for what you use. But the downside of that is if you don't use it, it's actually shuts down your entire function process. So I haven't touched this one since yesterday, because I tested this demo yesterday just to be sure it works today. So it's really shut down right now. So if I upload a new blob, let me just show for a quick second. As soon as the entire import process of my file, of my blob is done, it will actually remove the blob from my container. And if I refresh now for a couple of times, you see that the file is still available, meaning that as we speak in Azure, my function project is instantiated and started up, and it takes some time if it's really shut down. So that's the downside of your consumption plan. You may want to take that into consideration as well. So now let's go to my front end, my client. I really like Angular. I'm not against React or Vue or whatever front-end framework and spas there exists, but I'm really enthusiastic about Angular. If you're not familiar with it, really don't bother. I'll just run through a couple of things that you need. In this client-side framework, there's a package manager called npm, maybe a little bit comparable with NuGet packages, and there's a package available for SignalR which you can use. It says ASP.NET. Let me zoom in right here. It's this ASP.NET SignalR package. If you include that in your project, then you have the client available, and you just have to configure and connect to SignalR, and you're good. So let's just go back to my page. As you can see, if I create a connection right here, I connect to my backend endpoint /API/import. And if we now go back to the serverless, to my server application, you see that the endpoint is actually named /negotiate in the end. And that is because this client that I use client side actually adds /negotiate to this path. So you need to take that into account because else you're connecting with non-existing with a non-existing endpoint. So basically, what this client does if it connects, the import /negotiate. But you can leave that out from your client. Now let's just go to the bottom of my page. You see here this ng-init, which is, oops, there's a tooltip, which is actually the initialization of my page. You can see that I first create connection, then I register on server events, and then I start the connection. So what we saw here was the create connection, and then it starts register on server events. And now I have two events that I handle. It's the new import and it's the update import. The new import obviously takes place when a new import process starts. And I just send this import status DTO, which is a data transfer object containing all the information that I want to know from my import process. Now, you see that all the properties here are capitalized, which is not JavaScript by default. But if you use JSON in your backend, your properties will be decapitalized if you send messages out. But for SignalR, it's not. So the property names need to be actually the same as they are on the backend. And you see that I also handled this update import, which contains update information of my import. And on my client side, I maintain an array with statuses, and I update the status inside that array depending on that same correlation ID. Now to invoke these messages from the server, for example, if I go to this status function, right here all the way on the bottom, you see that I here generate this import status DTO and add all the properties that I'd like to send to my client. And then I just create a new instance of a SignalR message. The target here, new import, that's actually the event I want to take place on my client. And let's just get rid of these panes to make it a little bit more readable for you. Oh wow, again a tooltip. And as an argument, I just pass that entire data transfer object to the client. So if I execute this line, code will be executed on my client in the browser. So now let's go back to my Cloud Explorer and see if the import file is still available. It's still there. Okay, that's always nice if your demos are not working while doing a live session. So let's just go and open the client, see what happens there. Nope, still nothing. So this is, oh, there it is. So this is my my web client, and it actually shows there's 1,000 users being imported. The green square is obviously the success messages, and the red square is when something goes wrong. And now let's just, in the meantime, start and upload a couple of more files, and then see what happens in the front-end side. And if I'm correct, then new import instances will be started, and new blocks of import processes will show up. Oh yeah, they're actually, oh wow. So one import process is complete. 739 users are imported, and there's the rest of my import. One file could not be parsed because it was an image, and the other two files are now started as new import processes, and the import process is running and now showing what's going on the server. So. And of course, there's one import that failed. I'm just looking in the chat to see if there's some questions. I cannot spot them. Nope. So let's
no questions so far.
No questions so far, which is nice. Thank you. So that's basically what I wanted to show you. Again, there's what we like to say in the Netherlands, there's multiple ways that lead to Rome. I don't know if that's actually a saying in English, but it means, is it?
We are seeing your slide.
Yeah, that's okay, correct. Yeah, that's correct. There's multiple ways leading to Rome, and I really wanted to share with you this event-driven way of importing data and stacking work on the queue, and thereby distributing load over multiple instances of functions and handling the payload for you. Now I want to thank you all for listening to my session. You can see my Twitter handle and my LinkedIn, but I think if you really like this session, my GitHub account will be more interesting for you, because this demo is entirely available on my GitHub, where you can download them or fork it and have it a go yourself. So that's it for me today. I think exactly within the 45 minutes. And
excellent timing. Excellent timing.
Yeah, thank you.
If there's any questions, feel free to ask them in the chat, and then Edward can respond to them. If not, I guess, Edward, if you want to hang out in the chat for a little bit, then people can ask questions there as well if needed.
Yes, of course I will.
Very interesting session, by the way.
Thank you.